natural, there we go. I'm in the Natural Resource Ecology and Management Department at Oklahoma State University in the lab of Dr. Craig Davis, and we already went over my title. So I guess we'll hop into it. I wanted to start by doing a thanks to everyone who's helped me out. So funding from the EPA, the Bolenbach Endowment at my Oklahoma State University, my technicians that have helped me the last few summers, my partners on this grant and this project, the Platte River Whooping Crane Maintenance Trust, and the other management organizations in the Central Platte River Valley that have graciously let me use their sites to collect data on. So that the first thing we need to talk about if we're going to address relationships in these wet meadow communities is exactly what a wet meadow is. So by definition, wet meadows are herbaceous habitats with waterlogged soil near the surface that periodically support standing water during most springs. So water will be standing in these systems for a couple months out of the year, like 3 or 4 months, variable depending on the flows, and they're fed, in this case, in the Central Platte River Valley, fed by the Platte River. They exist along a gradient between lowland prairies and shallow marshes, and the gradient they exist on is both a hydrological gradient between those two, as well as an elevational gradient between the lowland prairies and shallow marshes. Some key features of wet meadows. So we have high water tables. Typically, throughout most of the year, we expect the water table in a wet meadow to be within about 1 meter of the surface. Poor drainages, again, due to the nature of the soil in these sites, they hold standing water for an amount of the year. Nutrient-rich soils, like you'd expect from a lot of wetland-type ecosystems. One of the major defining characteristics of wet meadow habitats is their vegetative community. It's carex dominated. Carex are a genus of grasses. Sedges might be another name you'd be familiar with. And then wet meadows are fed by flow through subterranean gravel deposits. Now this can actually get the ecosystem into trouble to some degree, because these gravel and sand deposits beneath the wet meadows can often be like dug up and mined and sold, and that of course destroys the ecosystem. So that's part of what gets them in trouble, and we'll talk about that more later. In terms of services provided by wet meadow ecosystems, they are important in nutrient removal and nutrient transformation, making nutrients more accessible to other organisms. Flood mitigation, because of their lower elevation relative to areas around them, then kind of serve as a buffer during peak flow events. Groundwater discharge or recharge, it can be a source or a sink of water into the water table, depending on their elevation and their relationship to the water table in general. And they serve as really good foraging habitat. In particular, they can serve as stopover habitat for migratory birds. In particular, the sandhill cranes and whooping cranes are known to utilize these ecosystems for foraging to some degree. So that kind of lets us narrow down to more of the topic that I want to focus on, which is the macroinvertebrates of this ecosystem. And in relationship to them as a food source for migratory birds, research has found that the macroinvertebrates of wet meadows comprise about 5 to 10% of the diets of sandhill cranes by volume. Now this seems like actually a really small portion, and it is. It's a small portion of their diet in total. However, it was also found that sandhill cranes will spend about 50% of their diurnal time foraging for the macroinvertebrates in wet meadow communities. So they're spending a lot of time trying to get the nutrients from the macroinvertebrates present in these systems. And part of that is because of the essential nutrients provided by the macroinvertebrates that they just don't get in other foraging habitat. So while not a huge portion of their diet, it is an important part of their overall diet. Now, why do we care so much? Why are we so interested in wet meadows? Well, one of the big things, besides the services they provide, is also that we're losing wet meadows. So they're kind of an endangered ecosystem. I think a lot of us are familiar with what's happened on the Platte River, anthropogenic influence having led to, such as dams and diversions, having led to about a 70% decrease in annual flow and peak flow of the Platte River. This has translated into about a loss of about 75% of the total wet meadows in the Central Platte River Valley. And then the good news, I suppose, is that restoration efforts have been underway and have been to some degree successful. for about the past 40 years. And these restoration efforts have been conducted by state, local, and federal organizations. So now that we know a bit about wet meadows and why we care about them and what they provide, we can talk about my research and what I'm looking at and what I hope to gain from my project working with wet meadow ecosystems. So I can kind of break down my dissertation project into three main objectives. First of all, refining understanding of relationships between below ground invertebrates and abiotic ecosystem variables. So kind of looking at how these macroinvertebrate communities vary with things like depth water, soil moisture, and bulk density in these wet meadow ecosystems. In addition, I want to relate below ground macroinvertebrate communities to wet meadow condition and functionality. So we'll talk more about how we're measuring condition and functionality of these wet meadows, but just seeing how, how these macroinvertebrate communities can change depending on how, I guess, the quality of the wet meadow that they're in. And then finally, part of my dissertation is to evaluate the Nebraska Wetland Rapid Assessment Method and its use specifically for wet meadow ecosystems, so a subcategory of the wetlands that it is intended for. So my study sites, I have 80 study sites in total, and they're all put onto this, all the points are on this map here, kind of stretching from Overton to Grand Island. You'll notice I have quite a grouping of them in the east, and this is for a couple reasons. One, the functionality of these systems tends to, and just of the ecosystem in general, tends to increase as you move east on the Platte River. And on top of that, I am partnered with the Crane Trust on this project, so a lot of the sites over there are Crane Trust property as well. So there's a bit of a clustering of sites there that I will have to deal with in my analysis and modeling. So far, I've collected data on 53 of these sites, so I've had 2 summers of field research so far, with one final summer planned during 2022. And we're going to try to get those final 27 sites and maybe even add some additional sites. We'll see. It depends on how the timing works on that. So I wanted to go over the methods that I'm using real quick. Once we get to a site for invertebrate sampling, we lay out this 100-meter sampling transect. And in this photo, you can actually kind of see that in the background. You can see the yellow tape measure running down the screen. And along this invertebrate sampling transect, we pull an invertebrate sampling block every 20 meters, starting at meter 0. And the sampling block is just a 25 by 25 by 20 centimeter block of soil that we will pull out and bag up, and eventually we'll take that back to the lab where we'll rinse through it, pull out the macroinvertebrates, and preserve them, and then ID them and get biomass measurements and things like that. Also along this transect, we take soil cores for bulk density and root density. So some of these environmental factors we're interested in comparing to the invertebrate community. We take depth to water measurements, and then we also do soil moisture measurements. So quite a battery of tests along this 100-meter transect. Now I wanted to show everyone kind of the kinds of macroinvertebrates that we find in these soil blocks and what we're dealing with here. So the first image you'll see on your screen is actually a larval Tabanidae, a horsefly that we found in some of the samples. And then here's a pupal form of Tabanidae as well. We then have Tapelidae, which are your crane flies. And this is a kind of head-on image of it. And here's an over-the-top image of what the Tapelidae look like when you're viewing them. Some ground beetles, of course, and then Scarabaeidae, your scarab beetles. In particular, this is a larval June bug. So far, we've identified 56 unique insect taxa. Now, I want to preface this, or add that we're IDing to family currently. So part of the reason is because we're more interested in functional groups than individual species. So of course, if we went to genus and species, this number would increase by quite a bit, but this is 56 individual families that we have so far in our set, and we still have more data to go through. The 3 most common families that we have within our data set have been Scarabaeidae, so those scarab beetles I talked about, Armadillidae, which are your roly-polies, and then Elateridae, or click beetles. So what we want to do with this data is we want to take it, and one of our first objectives is to compare to previous macroinvertebrate studies done in this area. So about 20 years ago now, my advisor, Craig Davis, actually did a macroinvertebrate study similar to this one in the area. And so this study, we're kind of taking the methods he used and upscaling it to more sites and a wider range of sites. So we're getting sites that vary a lot more in their flooding frequency and in their soil types and in their placement along the Central Platte River Valley. And we want to compare, our macroinvertebrate data to some degree to what was done 20 years ago. But of course, we have a larger scale for this, larger scope. As I said in my objectives, we want to construct relationships between invertebrate community and wet meadow features. That's why we're collecting so much environmental data at each of these sites. And my early analysis, which I'm going to talk about a bit later on today, involves modeling. So in particular, I'm using Bayesian generalized linear models early on to just look at relationships between these communities and these environmental factors. I also wanted to go through our method, the rest of our methods. So vegetation sampling, this is also done on a 100-meter transect, but it has a 10-meter offset from our invert transect. And it's just Daubenmeier frame for identification and classification of the vegetation all along that 100-meter transect. And we hope to take that data and not only calculate wetland indicator scores, but also compare it, of course, to the macroinvertebrate community. And kind of the last part of my project in terms of methods that I'll talk about is the Nebraska Wetland Rapid Assessment Method. So the rapid assessment methods, of course, are metrics to monitor ecosystems and inform management. They're supposed to be a quick way that you can collect a couple variables and assess the overall health of an ecosystem. And this is really good for managers who want to, have something quick that is quantitative that they can kind of do to figure out if their management is working. The NERAM was developed to evaluate functional and ecological conditions in the wetlands of Nebraska, of course, developed by Ted LaGrange, who may or may not be in the group today. I know he was in some of the sessions yesterday. So the scores are calculated from a total of 6 factors, and these factors vary in whether or not they're field data or data taken that you collect in the lab through like GIS or something, such as a watershed land cover. It's one of those that you would use GIS for. So getting on to my analysis that I have for today anyways, and this is of course a preliminary analysis, right? We're pretty early in the analysis phase of this study. We still have a whole other summer of data to collect, and I'm still processing some of the samples from this last summer. But what I have gotten processed, I've analyzed a little bit. As I said, I'm using Bayesian generalized linear models. And what I'm doing is the first models I kind of used were trying to predict wetland indicator score using macroinvertebrates and ecosystem variables, right? So I was trying to find relationships between the macroinvertebrate communities and wetland indicator score. Just a quick overview of what wetland indicator score is. There are scores, so wetland indicator scores are assigned to individual plants, and then you take a weighted composite of those vegetation scores to calculate overall wetland indicator score for a site. So once you do this calculation, you get a number, and if that is less than 3, you're probably in a wetland ecosystem. If it's about 3.0 to 3.2, it's more of a transitional type of ecosystem. And if it's greater than 3.2, you're usually more in an uplandy ecosystem. So, like I said, trying to predict that variable based on the communities present. So I looked at a number of predictor variables, right? So I had Tepelidae, crane flies, my scarab beetles, click beetles, as well as factors such as longitude, flooding frequency, soil moisture, and then, of course, combinations of these variables as well. So I won't get too far into the model selection procedure, but I used a leave one out cross-validation, which I can talk about more in depth later, or more in depth if anyone wants to know about how that works. But essentially it told me that my top 3 models for predicting wetland indicator score, and they're pretty close to one another in terms of their score, were flooding frequency and Tepelidae, just presence or absence, not biomass. Second best model was actually just Tepelidae presence or absence, and the third best was longitude plus Tepelidae presence and absence. So really interesting to see Tepelidae as such a really good predictor of the wetland indicator score. So taking the posterior distributions of this model, I was able to just plot the score predictions based on the presence or absence of Tepelidae. And so you can look at this box and whisker plot showing these two distributions and how it varies. Just if you detect Staphylidae at all, the model anticipates that you've drastically reduced or dropped your wetland indicator score. And remember, you want a lower wetland indicator score if you're in a wetland, below 3.0. And then if you calculate between these two distributions, there's a 99.8 probability of difference within the model in these two output distributions. So that's just a quick little analysis, specifically dealing with Staphylidae in that case. I, of course, want to do more of this with more of the insect community and try to do predictions using the macroinvertebrate community in aggregate. So we have to analyze more of the insect data still. There's also soil analysis that we're conducting. We've sent away all our soil samples to a soil testing lab here at Oklahoma State University. And we're waiting for those to get back to us. Need to calculate wetland indicator scores for more sites. So the analysis that I showed to you today was actually conducted using only 30 of the total 53 sites that I have collected data on. And that's because we haven't gotten the wetland indicator scores calculated yet for some of the sites from this last summer, because it can be a lengthy process. I also need to examine the earthworm community, and this is where a lot of really interesting information could be. There's native and invasive varieties of earthworm present here, and it'd be really cool to see how those sort of correlate and predict within a wet meadow ecosystem. And then finally, I need to actually get around to computing the NERAM scores, which is, sounds like one bullet point on my to-do list, but it's actually a lot of bullet points, because I got to go through GIS and do the watershed classification. I have to look at all the environmental data we've collected specifically for this, and then use that and get the total calculation for that. So quite a bit to do there. But now that I've explained my project, where we're at, and some early analysis and where we hope to go, I want to thank you all for being here today, and I'll take any questions.
All right, thank you, Abraham.